Hello, everyone. In this video, we will present several algorithms in the search for an efficient algorithm for finding the greatest common divisor of two integers. In chapter 5, we presented a brute force algorithm for finding the GCD of two integers m and n. These are two integers m and n. We'll find the GCD and return the GCD. To find it, we look for all the possible divisors k starting from 2 and all the way to a number that is less than or equal to m and n. If this k is divisible by both m and n, so k is the new GCD, but we need to continue to search and all the way and for all the possibilities, and when we go to up to m or n to see if this k is divisible by m and n. So this is the program. It's a very natural program, so this is called the brute force algorithm. Brute force refers to an algorithmic approach that solves a problem in the simplest or most direct or obvious way. As a result, such an algorithm can end up doing far more work to solve a given problem than a cleverer or more sophisticated algorithm might do. On the other hand, a brute force algorithm is often easier to implement than a more sophisticated one. The complexity for this algorithm is obviously order of n. We can improve it. We don't have to do it for the numbers. Here the numbers starting from 2, we look at a k, the possible divisors. And well, if 2 is a divisor, and we continue to look at, see if the divisors, for say 3 and 4 and 5 and so on is a possible divisor. Now, if we do the other way around, we're going to start for the k is for n. Let's assume that n is less than or equal to m. So look at the starting from n. As soon as we find a k, which is a divisor for both m and n, and then this k is GCD, we can break. So this is slight improvement, but the overall complexity is, in the worst case, it is still order of n. And further, we can improve it. We don't have to start with n. We can start from half of the n. So we can go with this is half of n and see if, and this k is a divisor, and this improves the efficiency, but the overall, in the worst time complexity, it is still order of n. Now we will introduce a very clever algorithm for finding the GCD, and this is called the Euclid's algorithm. It was discovered by Euclid around 300 BC. This one is the oldest non-algorithm. It can be defined as follows. If m remainder n is 0, GCD mn is n. Otherwise, GCD mn is reduced to GCD n m remainder n. The algorithm is actually mathematically easy to prove. So there's one simple paragraph in the book and see how this is proved. I'm going to leave it for you to study in the book. This is natural recursive definition. So we can implement it using recursion simply like this. And to compute the GCD Mn, if m remainder n is 0, return n, else return GCD n m remainder n. This is actually a tail recursion, so this is very efficient. The time complexity of this algorithm is order of log n. For the mathematical proof, please see the book. That's all for this video. Thank you for watching. See you on the next video.